All right, today we're diving into something that might just flip the script on everything you thought you knew about your brain and aging. For like 100 years, the story was always one of slow, unavoidable decline. But it turns out the latest science is painting a picture that's way more dynamic and honestly a lot more hopeful. So let me just ask you this right off the bat. What if that whole idea that your brain hits its peak in your 20s and it's all downhill from there? What if that's just flat out wrong? I mean, what if the real story is one of constant reinvention? Because that is exactly what the new science is pointing to. For the longest time, the thinking was pretty simple. Your brain is like computer hardware. Once you're an adult, that's it. It's set in stone. But this new view, whoa, it sees the brain more like a piece of architecture that's always being remodeled. It's not static at all. It is incredibly, profoundly active. And listen, this wasn't some fringe idea. This was mainstream science for most of the 20th century. It was in the textbooks, it's what doctors were taught. Your brain was a machine, it got built, and then that's it. Any changes after that, well, that was just seen as damage or decay or disease. It was a pretty grim outlook, you have to admit. So what changed? What could possibly flip a century of scientific thought on its head? The answer is simple. Data. A mountain of data. See, by the mid-2020s, scientists had been collecting brain scans for years from these massive projects, and suddenly they had this unbelievable data set. The real breakthrough hit in 2026, when all that info was finally put together. And what they found? It didn't just tweak the old theory, it completely blew it out of the water. A brand new chapter for neuroscience, right there. And this led to this really cool new idea called structural brain shifts. Now, this is key. It's not just about the brain getting smaller. Nope. It's about this ongoing, lifelong process of remodeling. So think less like a statue slowly crumbling away and more like a bustling city that's always under construction. And get this whole process actually speeds up as we get older. Okay, so you're probably asking, how do we know this for sure? Well, the proof, the core evidence for this whole remodeling brain idea, it really stands on four main pillars. These are the specific, measurable changes that scientists found when they dug into all that data from 2026. So we're going to walk through each of them. First, what's happening in the cortex, then the brain's internal wiring. After that, we'll look at the deep structures, and finally, the big picture, how the whole communication network reorganizes itself. Let's kick things off with the cortex. All right, pillar number one. What's so wild here is that the change isn't happening everywhere at the same speed. The cortex, that's the wrinkly outer layer of the brain, it actually thins out at different rates in different places. And you can see it here. After a certain point later in life, the parts of your brain that do complex thinking start thinning almost 4 times faster than the basic sensory parts. So it's not a general breakdown, it's very, very specific. Okay, pillar 2 is all about the brain's wiring, what scientists call white matter. And honestly, the best way to picture this is as the brain's information superhighway system, right? These are the massive cables connecting all the different parts, letting them talk to each other super fast. And the health of these highways, well, it's absolutely crucial for everything the brain does. And here's where we see another major shift. Once we hit our mid-60s or so, the quality of these connections starts to drop off more quickly. This happens especially on those big, long-range superhighways, the ones that connect the most important brain hubs. It's kind of like the major interstates across the country starting to get potholes. It just slows everything down between the big cities of your brain. Moving on to pillar 3. This shows us the remodeling isn't just happening on the surface. We're going deep inside the brain now, where different parts are on completely different schedules. I mean, just look at this. The hippocampus, which is so important for memory, it holds steady for decades, and then bam, it takes a sharp dive around age 70. But then you look at other structures, and they have a much more gradual, steady decline. It's not one size fits all. And that brings us to the fourth and final pillar, which is really about what happens when you pull it all together. See, the brain's network is set up to be super efficient, something called a small world network. The easiest way to think about it is like a social network, where you have a few really popular people who connect tons of different groups. Well, this is where that organization starts to get a little messy. As those key connectors weaken, the whole network just doesn't work as smoothly. Yeah, the researchers use some pretty technical language here, but what it boils down to is actually pretty simple. Communication gets less direct. A message that used to take a direct flight now has to take a connecting flight, or two. That rich club of super connected hubs starts to lose its power, and the whole system just gets a lot more fragmented. So, okay,
We've got these 4 different things changing, gradually over decades. But here's where the story takes a dramatic turn. The research found that it's not just a slow, steady decline forever. There's a critical moment when all these slow changes suddenly add up and the whole thing tips over into a cascade.
And the data was shockingly specific about when this happens. It's a window, somewhere between 70 and 78 years old. Now, that's not just a random number. This is the age range where decades of that slow remodeling finally seem to hit a wall, a critical threshold. This is it. This is the tipping point. The brain is incredible at compensating for change, but during these years, it's like it just runs out of road. It gets overwhelmed, and what comes next isn't a gentle slope. It's more like falling off a cliff, a rapid decompensation. All 4 of those changes we just talked about, they suddenly hit the accelerator all at once. Okay, I know that sounds pretty scary. A cascade, a tipping point, but hang on, because this is actually the most exciting, the most hopeful part of this entire discovery. Why? Because if you know where the cliff is, you can put up a fence, right? If you can identify a tipping point, you create a window of opportunity to do something about it. And that changes everything. What this discovery really gives us is a target, a specific time to act. It opens up this critical window for what's called secondary prevention. And all that means is we have a chance to step in and support the brain's structure before things go wrong. The goal is no longer just damage control. The new goal is to be proactive, to push that tipping point as far into the future as we possibly can. So what would that even look like? Well, the research points to some really promising directions. We're talking about new strategies that could target things like brain inflammation or the health of its blood vessels. We might be able to develop treatments that make our brain's connections stronger, more resilient. And maybe the coolest part? We can use new brain scans to actually monitor this process, to see for each and every one of us when our own personal window of opportunity is opening up. So when you put it all together, the story of the aging brain, it's just not a story of decay anymore. Not at all. It's a story of constant, active, lifelong remodeling. Which leaves us with a really powerful final question to think about. If you know your brain is an active construction site for your entire life, what are you going to do to help it build something amazing?